اوكي بلشت ريكوردينج، فينا نبلش.
Right. I start?
يس يس.
Alright. Hey guys, how are you? أنا اسمي محمد كنيو and I'll be your advanced data science instructor. So اليوم حنحكي عن deep learning. What is deep learning? A small introduction of neural networks and what is neural networks and the difference between supervised and unsupervised learning and why deep learning is taking off. So, as you probably know, deep learning has transformed traditional internet business like web search and advertising.
محمد عندك
Uh,
presentation.
yes, عندي
Yes,
presentation.
you
I
share
will,
your screen.
but I'm not gonna. الله. Okay, يلا ثانية. ثانية. Okay. So can you see my screen?
Not yet.
Yes, شوي.
Yes.
You can see.
تمام.
وهلا is it still presenting?
Yes. تمام perfect.
Oh, yeah. Yeah. So I was saying هنحكي عن what is AI and how and we're gonna talk more about deep learning. Uh, but first, let me give you a bit of introduction about AI. And AI is basically, for me, it is the new electricity. Electricity started around 100 years ago, and the electrification of our society transformed in major industries. So بتشوفوا electricity now in literally every industry, in the technology, in the manufacturing, in the transportation, and everywhere. And today, we can see a surprising clear path for AI being an equally big transformation. So we cannot see anymore industry where it is not AI powered, and if it is not, it is going to a big decline. So today we're going to talk about deep learning being one of the highly skills in the technology world today. So what is deep learning? Deep learning refers to the training of a neural network, and sometimes a very large neural network. And what is a neural network? So neural network. Let's start with a housing prediction example. Let's say you have a database with around 6 houses, so you know the size of the house in square feet or square meter, okay, and you know the price of the house, and you want to fit a function. Uh, we do. You want to fit a function that is to be able to predict the price of a house. So if you are familiar with linear regression, you might say that, well, let's put a straight line like that. That should be a better straight line, and you and you'll be able to put a function where it can predict the price. So instead of a straight fit line, we eventually become a hone. It will go negative, and we know that in the prices we cannot have a negative price. So you can see it will go into like a straight line, then it will go up like that. And this straight line, okay, بتصير اسمها something called a ReLU function. A ReLU function. Okay, if you don't know what a ReLU function, that's fine. You'll get to know it later in the course. And but this function اللي عملناها is the simplest function that we can have as a neural network. Let's say we have هون an input size x, Okay, which is the house. So size. Is there? I can't see the recording. So if someone has a question, just say.
Guys, what is the name of the function?
So the neural network is a function. So when you want to put a neural network is basically a function, and this function can depend on every type of application that you're trying to use on. For this application, now we're using a house price prediction, and this line that you see is called the function. Okay, so now when we want to predict the house the price, فنحن we try to fit it on this function, on this best fit line.
Okay, thank you.
Okay, so we have a size X, which is the size of the house. Okay, and one second. وهون it takes something called a neuron. Okay, it's a circle, and it predicts price Y. So price. So this neuron, my handwriting is bad, so forgive me. So this neuron, this little circle, is a single neuron in a neural network, and it implements this function right here. Okay, and this computes a linear function, as you can see, and then outputs up an estimate price Y. Okay, and in the neural network literature, you'd see this function a lot, which is the ReLU function. Most of the applications today, they use a specific activation function, which might be looking like this, where it takes a 0 and goes up to a certain number, the maximum. So the minimum number that we have is going to be 0. Okay, and ReLU, this function is called a ReLU. It means rectified linear unit. Okay, and it just means that it takes a max of 0, which is why you get a function shaped like this. Okay,
بس لانه
so
بالكيس اللي انت اعطيتنا اياها هون انه ما في عندنا برايس نيجاتيف، كرمال هيك ريكتيفايد
exactly,
بدنا نبلش from zero.
exactly. So, but this is an example of a really like a simplest kind of neural network, which takes only one neuron. So if you think of this neuron that's being like a single neuron, a single Lego brick, you can get a bigger neural network by stacking them together of these Lego bricks. So for example, إذا بناخد something more complex is هون بس عنا like two we have only the size of the house. But if you want to add more neurons, we'd stack them together. Okay, let me give you an example. And we can see that instead of predicting the price of the house just from the size, you can get other features. And on the other and some other features could be well, we can say the size. Okay, other features could be the number of bedrooms. Okay, and the size and number of bedrooms can tell you, for example, the family size. Okay, and you can fit like a family of 3, a family of 4, or whatever, and it's really based on the size of مثلا the square meter and the number of bedrooms that determines the family size. And you can even add more and more features. مثلا address might affect the price of the house. So if you're uni students مثلا if the house is in Hamra and you're in your university is in Beirut, okay, and your house is in let's say, I don't know, in Jnoub, it might be more expensive, it might be cheaper since the distance is farther. So you can see the walkability. That's another neuron. You can see it stacking. You have the address might affect the size, the price of the house, and you might also add مثلا wealth. Okay, might affect مثلا the school quality, might help مثلا المدرسة. It might give you مثلا if the parents are richer, okay, it might give you better school quality, and since there's better schools, there are more expensive homes. Okay. This can also مثلا happen هون. So each of these little circles I'm drawing can be one of those مثلا ReLU functions, since they cannot be zero. And based on the size and the number of مثلا bedrooms, you can estimate the family size, and you can estimate the walkability, the wealth, and the school. And finally, you might think that, well, the way people decide how they're willing to pay for a house is they look at these kind of things: the size, and the walkability, and the address, and the wealth. And that's the things that really matter to them. Okay, and these kind of things will help you to make a prediction of the price. So since we added more features, we can have a kind of more detailed layer on how we're predicting the price. And here you can see in this example is how a basic neural network looks like. But the difference between the one previously is that we saw that here only the size would go for the family size, and the bedroom. However, in this neural network, it would go to every single neuron. And it is the job of the neural network to actually know which neuron it should fit best. So, and the neural networks really does a very good job knowing which neuron is the best for it. And we can see مثلا هون the x1, x2, x3, x4 is the size, the bedroom, the address, and wealth. And y is the price of the house that you're trying to predict. And by stacking together a few of the single neural networks, you get a simple predictor. And here, this layer, okay, it is what we call the hidden layer. And typically, we don't really know what happens in the hidden layer, okay? But if we give it, all we can control is the input layer. If you give it good input layer, then the neural network does a very good job to know and to make these kind of neurons where we set the family size, the walkability, and school quality. So it will able to do this by itself. And this is really the power of neural networks. Okay. Okay. So yeah, that's one. Just give me a second. Yeah.
Interesting. محمد مين بيعمل definition للX1 والX2 والX3؟
Yeah, you are the ones who give these X1 والX2 والX3 هدول we call them input layers.
مين
والinput
بيعمل
layers
كمان الداتا ساينتست؟ يعني من شغل الداتا ساينتست، من الريسبونسبيلتي تبعت الداتا ساينتست انه كمان هو يعمل definition للانبوت.
Yes, exactly. So نحن sometimes هلا you're gonna see even later on in the slides إنه نحن the more data that we have, okay, the more accurate we can give a neural network. But sometimes نحن we don't have a lot of inputs. So بتيجي data science skills to make something called feature engineering where بيخلق more inputs, okay, for it to تحط على الموديل to be able to make more neurons for it to have a more accurate predictions.
اوكي. يس علي.
سوري، كان عندي question بالنسبة للنيورال نتوركس. هلا نحن بنقدر نكون عم نعمل بالنسبة للشيء شايفه قدامي، بالنسبة للإنبوت والهيدن والأوتبوت لاير، بنقدر نكون عم نعمل نحن classification by back propagation منشان نعمل reducing للerror اللي هو ال y من خلال updating the weights in a backward form.
Yes, exactly. This is what we're gonna be going on later on the course. هنحكي عن backward and forward propagation, وهنحكي عن how to even build the neural networks.
Okay.
Okay. بس هلا for first I'm giving مثل a basic introduction of what is a neuron, of what is a neural network, كيف تشتغل. بعدين I'll jump into these topics. Okay.
Oh, okay.
So yeah, the next one نحكي عن supervised and unsupervised learning. There has been a lot of hype between neural networks and some of this are between supervised and supervised learning. But to be honest, most of the economic value that has been created by neural network has been gone through supervised learning. And home, we can see some examples of supervised learning. You might have supervised learning يعني عندك an input X where you put information and you get an output Y. And we can see that we have many applications that are very helpful that it is being used in today. So the first one is هلا اللي عملناه مثلا the house predicting the house prices, the real estate application. Okay. where مثل ما شفنا حطينا كذا features مثل size والwealth and etc. بيطلع لنا price Y. Okay. The second one is the ad, and ads is actually one of the most lucrative money making machine learning application that we have today, as it puts an info about an ad and to the website, and it's thinking of showing you if this person would click on the ad or not. And neural networks have gotten very good at predicting whether or not you'd click on the ad by showing you and showing users the ads that you are most likely to click on. This has been, to be honest, making a lot of money for companies, and you can see that sometimes one of the basic applications could be simple yet making you money. So sometimes when we want to make a machine learning application, we don't have to really look at the fancy ones. Lately, like you're seeing the rise of ChatGPT and so on, but you can see that machine learning could be applied somewhere else, but it's not very appealing to the media to show about online advertising. So that's why they focus on something else. The second thing is computer vision, and to be honest, computer vision is one of the specialties that I'm currently working on. Computer vision has made like huge strides in the last several years, mostly to deep learning. So you might input an image and want to output an index, say from 1 to 1000, trying to tell you if this pic might be any of, let's say, one of 1000 images. So you do something like photo tagging and some image projects, applications that you can use is object detection and classifications, whether identifying, let's say, this is a cat or this is a dog and so on. The fourth application هي الaudio. And in recent progress, we have speech recognition has also been very, very exciting. And you can input now an audio clip and to a neural network and it will output a transcribed text. So هلا حتى you can see in many of the applications where you send a voice note وعلى طول بيعمل لك text transcription. These are one of the use cases of supervised learning. The other one is machine translation. Now, machine translation is very interesting لأنه ChatGPT uses a model called Transformer. And Transformer essentially begin by helping models to translate better. Some translations would literally predict in a literal meaning and not in the context meaning. So they use a model called Transformer to help translate better by predicting the next probable word. And this they found out, okay, we made ChatGPT from this, we made a generative AI from this, but it is actually the main use case for this was for translation. Now you can basically translate to many languages, and one of them is to Arabic. Okay, and هلا these use cases in أغلبكم you have seen this in many cases هلا, we got kind of used to it. The final one is called image and radar info, and you would give like an image and it would tell you the position of the car. And people who might use this are مثلا in Tesla and more recent car companies for autonomous driving. So you'd have like a picture and a radar, and a neural network can be trained to tell you if the position of the other cars on the road. This becomes a very key component for autonomous driving. So a lot of these, a lot of value creation through neural networks has been through cleverly selecting what should X be and what should Y be, and for your particular problem, and then fitting your supervised learning component into an often bigger system, مثلا such as an autonomous driving, machine and translation, whatever. So we have to really identify our X features. We have to know what we're trying to predict, وبعدين we can put all of this into a real world application. And okay. And for okay, here are some literatures that you might see of neural networks. The first one is the standard neural network, which we have talked about earlier, and the second one is an example of convolutional neural network, which is often used in computer vision, where we will talk deeper into this in the later courses. Where it reduces the image pixels. Okay, the last one is a recurrent neural network, and recurrent neural network is also used for one-dimensional 30%, which is these, to see how it's performing. Okay. هون another one is about the ads. You can see عنا عنا user age and ID and so many things in the middle, like we have so many other features. هون it is depending on you how you'll be able to feature engineer, or maybe you already have this data given to you. وبعدين we try to predict if the person has clicked or not based على the inputs that we had here. Okay, مثلا age can play a factor, and so on. And the other unstructured data, okay, is the audio or the image or the text. So نحن with the rise of digitization, so عندنا many forms of data rather than before. So صار عندنا audio data, which is again through time. Okay, it is a one-dimensional data. Okay, وعندنا الimage, which is a pixel based, so we have a lot of pixel. كمان this cannot be formatted in a structured way, in a tabular way, so that's why بتصير اسمه unstructured. في عندنا text. Text could be all forms of text, whether on a Word document, على Twitter or X, or basically any على website حتى. So you can be able to extract this information, extract this text, and make more insights through this. Okay, هلا بس recently, or actually the most applications that are being used today at work, you'd see them more on the structured data. Okay. So why is deep learning taking off? And we have seen this going for many years. Well, algorithms exist for many years. Why is it today that it is performing very well? It is mainly a transformation of many things, and let me draw it in a way that you'd be able to understand it. And today, the traditional neural network, okay, would be this is the amount of data and this is the performance. And if you want to perform a simple neural network, a traditional neural network, okay, you'd see it. This should be going horizontal. Okay, this would be, for example, the traditional neural network. And by traditional, I mean either when it comes to structured data. يعني it could be a regression-based model, it could be a classification-based model. مثل ما شفنا يعني ads, predicting ads is a classification model, since it is either a yes or no, or a regression-based where we're trying to find a price or a specific number. Okay, and the performance improves for a while as you have more data, but after a while the performance pretty much plateaus home. And while it is true that sometimes the more data that we have, the better, but we might need some kind of a bigger kind of models that would perform better. And you can see here, مثلا, if you use a smaller neural network, please use different color. If you use مثلا a small neural network, it's gonna go like this. Okay, and if you keep adding a more complex neural network, it would be even more and more complex. So نحن بنشوف the algorithms that we're using, if they become more complex, okay, we can see a better performance of the models. And in recent years, okay, we can see that we're having more innovation بالmodels, بالalgorithms, which are creating models to perform even better. So this is a large. large neural network. Okay, and sometimes performing a very large neural network might not really be the best idea, because performing a very large neural network would cost a lot and a lot of time. يعني through my experience, you could be seeing weeks of training a large neural network, and with this, it could really cause a lot of issues. So we don't usually always go for the larger neural networks regardless. And if you want to hit this kind of high performance, okay, you either need a big enough neural network, okay, to take advantage of this amount of data, or you can use a smaller data, okay, but we can use more feature engineering. So you can see here in this area we have a small kind of data. We don't have much kind of data. So هون نحن we try to seek for a traditional kind of neural network in classifications or regression, and with the use of feature engineering is بنعمل extra inputs for the features. هون we can see that the traditional neural network might even perform better than the larger neural network. And so sometimes if we have a small data set, that doesn't mean a larger neural network will always be the best use case. Okay, في any questions? Okay. And هون we can see that if we have more data, okay, and we have more computation in a big neural network, we can see a better output and better performance. It is true in some cases, but as well, this might compute a lot of time, and the ability to train very large neural networks either on CPU or GPU has also enabled us to make a lot of progress. So we did not have this kind of performances and GPUs that we had back in the earlier days. But nevertheless, we have seen also yet a lot of algorithm innovations in the past few years, which try to make algorithms run faster. The neural network that we're seeing new kind of neural network algorithms that would run way faster than the other. And one example of a huge breakthrough in neural network has been switching from the sigmoid function, which looks like this. Let's say this is goes like this. Sigmoid switches from the sigmoid function to a ReLU function. ReLU حكينا عنها هيك تكون هيك. And if you don't understand this, it's okay. But one of the problems of using a sigmoid function in machine learning is that there are these regions هون. هون. Where the slope of the function, where the gradient descent is nearly zero, and so the learning becomes very, very slow. And because when you implement a gradient descent and the gradient is zero, the parameters change and becomes very slow, and the learning becomes extremely, extremely slow. However, if we change the activation function to use the ReLU, the gradient descent بتصير هون close to 1, and we see that we have all positive values in the input, and making the gradient descent much less likely to shrink. And the slope line would be extremely high compared to the sigmoid. And see how the sigmoid is slope line is equals to 0, since we don't have a slope. And this is just an example of one of the algorithmic innovations that we had, which really increased the algorithms and to perform way better. And this is I'll talk also deeper later on what is gradient descent and how it works. Okay, and why do we need gradient descent to improve our algorithms? Okay, and one other topic that why we're having better AI performing today is mainly that before, when we had an idea, okay, we would execute this code and we would experiment. And instead of these taking like months to train, we're now taking it for example, like 3 or 4 hours. And once this finishes, we have more ideas to compute. And if it's taking you 3 months to, for example, ChatGPT took 3 months at the first time ChatGPT came out, it took 3 months to train. And this is a lot of time, okay? But the more time it's taking, the more difficult it is for you to create new ideas and to try new things. So by experimenting and you're having a much shorter time, you are able to come up with more and more innovations. And this would also help us while we're seeing more progress in deep learning today. So this is basically what we're going to be talking about, and we're going to go talk deeper into AI. But this is for now a kind of a brief introduction of what is neural network and the difference between supervised and unsupervised, and we're going to be talking about more algorithms and how they work, such as convolutional or recurrent neural network. وكمان we might be working on a project سوا. I have still not decided what kind of project we're going to be working. Maybe it's going to be like a time series data where we can use like recurrent neural networks, or if you guys have a specific curiosity on we want to use some convolutional or something else, I'm also open to this idea. Then I'll show you on how we can build this model together, and you'll be able, inshallah, by the end of this course, you'll be able to with all confidence be able to understand how to implement it and also how it works under the hood. كمان most of the work today ما بيسألوك if you know how to implement it or not. Basically the code is available everywhere. They really try to look on understanding which algorithm you're really using, why you're using this, why you're using this activation function, okay, and how can you optimize this algorithm. Okay, so definitely we're going to walk through these kind of topics, and inshallah by the end of this internship you'll be able to have a very confident and solid foundation and move on to build a very great projects. Yeah, thank you.
Thank you, محمد. حدا عنده سؤال؟ Okay, thank you, Lakan. See you next week. Bye.
Thank you so much.